Two vertical poles, PQ and ST, are secured by a rope, PRS, going from the top of the first pole to a point R on the ground between the poles, and then to the top of the second pole as in the figure. So in other words, we have PQ as one of the poles, ST as the other pole, not necessarily equal to each other, and then R is going to be the point on the ground. So QRT connect here on the ground, and the rope is PR and RS. Show that the shortest length of such a rope occurs when theta 1 is equal to theta 2. So this is theta 1 and this is theta 2. Because it's vertical poles, these are going to be 90 degrees. So we want to minimize the rope. By minimizing the rope, we want to show that theta 1 is equal to theta 2. So want to show theta 1 equals theta 2 when the rope is at a minimum. Okay, for that we're going to label this right triangle, or these two right triangles. So we'll do this in red. We'll call this length A. We'll call this length X. And we'll call this whole distance D. Now ST we'll call it as B. And so because this whole length is D, this is X, we have a part plus part equals whole. This has to be D minus X. Okay, and by using Pythagorean theorem, we find that this is the square root of a squared plus x squared, and this is the square root of b squared plus d minus x squared. So we have all sides of the triangle labeled. So now let's come up with an equation. So the rope, the length of the rope is PQ, PR, which is square root of a squared plus x squared, plus RS, which is b squared plus d minus x squared. And you can think of this as our function. We want to minimize this. How do you minimize? Let's take the derivative. But before I take the derivative, let's just rewrite this as whatever is inside the parentheses raised to the 1/2 power. Now let's take the derivative. So we have to apply the chain rule. Now the chain rule for the second derivative is a bit tricky because we have to use another chain rule. So we're bringing down the exponent, keeping the inside the same, subtracting 1 in the exponent. And now taking the derivative of the inside is where we have to use another chain rule. The derivative of b squared is 0, and then for d minus x squared, we bring down the exponent, subtract 1, and then we take the derivative of the inside, which is a negative 1. And now we can simplify a bunch of things, or a couple things rather. We can just eliminate the 2's. And I'm going to rewrite this as the square root on the bottom. And then this negative is going to come out in front. And so we're going to have the square root b squared plus d minus x squared, and then d minus x at the top. Set this equal to 0 because, again, you want to find the critical point. Now, let's look at what we have so far. Okay, in reference to the triangle, what is x over the square root of a squared plus x squared? Well, I have x here, and then I have the square root of a squared plus x squared. What is that in relation to theta 1? Because we want to show theta 1 is equal to theta 2. Well, that's just the cosine of theta 1. Okay, what is d minus x over the square root of b squared plus d minus x squared? D minus x is here, and then square root of b squared plus d minus x squared is there. That's also cosine of the angle. We're going to show that these two, when subtracted, equal to 0. Well, that means that cosine theta 1 is equal to cosine theta 2. Okay, when is cosine equal to each other? So if I have cosine of an angle equal to cosine of another angle, when are they equal? But before I answer this, we want to make sure that theta 1 and theta 2 have to be between 0 and 90. Okay, why am I saying this? We have a right triangle. That means This angle plus this angle have to equal 90. Same thing with this. This angle plus this angle have to equal 90. So it's bounded above by 90. It cannot be 90. Otherwise, the other angle is 0. So it's less than 90, but it has to be greater than 0 because obviously you need to have you need to have a triangle with 3 angles. Okay, so when in the unit circle is cosine equal to cosine? Well, they have to be in the first quadrant, and they have to be the same angle. So theta 1 is equal to theta 2. Okay. Now, how do we show that this is a minimum? This is a little bit of hand waving. So you kind of have to use common sense here a little bit to find the critical point. Well, what happens when these two angles are the same? What is the distance? What happens to this distance? Well, it's pretty obvious, hopefully, that these two triangles are similar, and that this point R is the midpoint of QT. I'm not proving it, but hopefully it's obvious. So the midpoint is the critical point, and so if I were to do the first derivative number line, the midpoint is d over 2. Why? Because we said the whole distance is d. The midpoint will have to be distance d over 2. Now we're going to test a point, let's call 0, and then test another point called d. Let's look at f prime of 0. F prime of 0, we'll look over here. 0 for x makes this whole thing 0. And then I have x over x becomes 0, so I have negative d over square root b squared plus d squared. This is negative because square root is positive, d is positive, but I have a negative. So this is negative. Now if I plug in d, this whole thing is 0. And now this is just d over the square root of a squared plus d squared. This is positive. So this is decreasing, increasing. D over 2 is a minimum. And we showed that at d over 2, we have theta 1 has to equal theta 2.